In the CAD CAM we are using the phi transformation, and these transformations techniques are employed for the purpose of viewing the image generated on the display surface, are called as the viewing transformation. The heart of any graphic system is its capability to perform the graphic transformation on existing data. Any graphical entity or drawing can be manipulated by using the transformation routine. There are a number of the transformation routine that we're going to discuss here. Gate sometimes asks the question based on the basic transformation routine. If a real drawing has to be produced using a computer, the limitation on the size of display surface possesses a problem. And there are only fixed number of pixels on the display surface. It is very difficult to accommodate the drawing as it is in the limited space available on the monitor. The coordinate values in the actual drawing may vary from one drawing to another. The device coordinate system in pixel is too restrictive for many applications. In that case, a programmer can adopt the transformation techniques to overcome such difficulty. So here we'll discuss the 5 basic type of transformation, that is scaling, rotation, translation, reflection or mirror, and the fifth one is shear. We'll start with the basic, that is the scaling, then we'll discuss the rotation and translation. In the scaling transformation, it is possible to enlarge or reduce the object, and therefore the scaling factors are used. In the case of rotation transformation routine, the rotation of any point is always effective with respect to some fixed point, and the coordinates of new point after rotation we are interested. Using translation routine, it is possible to translate or shift a point or object in either x direction or y direction or both x and y direction. The first transformation routine is the scaling. By using the scaling routine, it is possible to enlarge or reduce the object. For this purpose, we'll define the two scaling function. Sx is the scaling function in the x direction and Sy is the scaling function in the y direction. Sx is nothing but a ratio of the new coordinate along the x direction divided by original coordinate along the x direction, and Sy is the new coordinate in the y direction divided by original coordinate in the y direction. As far as the scaling transformation is considered, what we observed is that depending upon the value of Sx and Sy, the object will be get enlarged or will get reduced. If the value of Sx and Sy both are greater than 1, then the object is going to enlarge. And if Sx and Sy are less than 1, in that case, the object is get reduced. To understand the scaling transformation, we'll consider here a rectangle. 2, 1 is the first coordinate of a rectangle. Then we have 4, 1, that is the point B. Then we have 4, 3 is the point C, and we have 2, 3 is the point D. So this figure represent here the original square, which is represented by ABCD, and we want to perform here the scaling operation. Suppose I select here the scaling function Sx equal to 3. In that case, we can calculate the new coordinate of the point by multiplying the original coordinate with the given scaling function along the x direction. Similarly, we can have the scaling function along the y direction. Let's say, for example, we have scaling function in the y direction is equal to 2. So we can calculate the new coordinate y prime using y, which one is original coordinate multiplied by scaling function in the y direction equal to Sy. So you have to transform all the points here A, B, C, D, and you can show here what is the new position which is obtained by scaling. Since here Sx and Sy are greater than 1, what we observed is that the new square form or a new rectangle form will be get enlarged. So we will prepare here a table for calculation of what are the new points or a coordinate of point A, B, C, D after scaling. So we have to calculate here the value of x prime as x multiplied by Sx, that is we have x prime is equal to 3 times of x, and we have y prime is equal to 2 times of y. Let's start one by one. We have point A. Point A has a coordinate of 2, 1. So 2, 1. 2 is multiplied by 3. that will become a prime will be equal to 6, and 1 is multiplied by 2, that equal to 2. So 6 comma 2. 6 is here and we have 2 is here. So this point is become our point A prime. Second point is B. The x coordinate of point B is 4 and y coordinate is 1. So we have 4 comma 1. New point will labeled as B prime. 4 multiplied by 3, that equal to 12. 1 multiplied by 2, that will be equal to 2. So we have 12 and the y coordinate is 2. So we have 12 comma 2. This one is our B prime. Then we have coordinate of point C. C has x coordinate equal to 4, y coordinate equal to 3. So we have 4 comma 3. After scaling, you will get C prime. 4 is multiplied by 3, that equal to 12. 3 is multiplied by 2, that will be equal to 6. 12 comma 6. 12 comma 6. This one is 6. So this one is line of 6. This one is 12. So this point becomes C prime. And finally we have point D. Point D has x coordinate equal to 2, y coordinate equal to 3. So we have 2 comma 3. After scaling, you will get the new point equal to D prime. 2 is multiplied by 3, that equal to 6, and 3 is multiplied by 2, that equal to 6. So 6 comma 6. So this one is 6 and this line is 6. So this point is same as equal to D prime. Since here we have selected the value of Sx equal to 3, Sy is equal to 2, that is Sx is not equal to Sy. So originally we have a square of size 2 by 2. Now it becomes a rectangle. 12 minus 6, that is 6, and 6 minus 2, that equal to 4. So your figure is get enlarged because we have Sx value is greater than 1 and Sy value is greater than 1. But if you select the value of Sx less than 1, Sy less than 1, then you will get a reduced figure. Our observation is that originally the point A from origin O at a distance equal to 2 comma 1, now the position has been displayed to the new position equal to 6 comma 2. So whenever you are doing the scaling, you have to take care that the point is get displayed from the origin. Second observation is that originally the delta x is equal to 2. Now delta x is 12 minus 6 equal to 6. It means that it does not preserve the length. So from this figure, we'll define the scaling function in the x direction. We have Sx is equal to, the new dimension is a prime b prime, a prime b prime divided by the original dimension along the x-axis is ab, or we have Sx is equal to, new dimension is d prime c prime. So we have d prime c prime divided by original dimension is dc. And we have the scaling function along the y direction is sy, which is equal to dA or AD prime divided by original dimension is AD, or we have sy is equal to c prime b prime. So we have b prime c prime divided by bc. So this one is how the scaling function along the x and y directions are defined. Some of the observations that you can note down from the scaling transformation is the figure get enlarged or reduced based on the value of Sx and Sy. At the same time, it is get shifted from the original position. It does not preserve the length also. Original value of delta x is equal to 2 and the final value of delta x is equal to 6. So it does not preserve the length. So we have delta x prime is equal to 6, whereas delta x is equal to 2. Similarly, we have delta y, that is the original dimension is BC distance is equal to 2, and we have delta y prime will be 6 minus 2, that equal to 4. So dimension has been changed. The third observation is that it does not preserve the angle also, except when the scaling is uniform. In this case, we don't find any change in the angles, but if you take a different figure, right rhombus, then you will find the angles has been changed if we have different value of Sx and different value of Sy. we have x1 is equal to x multiplied by sx, and we have y1 is equal to y multiplied by sy. This information we can write in matrix form. We have x1, this column matrix is same as x, y. Now here for x1 only it is multiplied by sx, so we have sx multiplied by x plus we have 0 contribution of y. Second equation is y1 is equal to y into sy, so we have 0 contribution of x and we have sy multiplied by y. So this one is called as the scaling matrix, that is represented by S. The second transformation technique is a rotation, in which we can rotate the point P above the origin O. Let's consider here a point P which has x coordinate equal to x and y coordinate equal to y, and initially it makes an angle equal to alpha. Angle you have to always measure anti-clockwise positive, so right now alpha is the angle of the point P. We want to rotate this point in an anti-clockwise direction by an angle equal to theta, and we are interested in the new coordinate of this point. So this point is shifted to the new point equal to P prime, which has a x coordinate equal to x prime and y prime. This time the angle made by the new point with the original point P in an anti-clockwise direction equal to theta. So we want to develop here a generalized expression of the x coordinate, y coordinate, angle alpha theta and the new coordinate of x prime, y prime. Now this one is a right angle triangle. Here the hypotenuse is same as equal to the radius r. So we can very well calculate the value of x, which one is adjacent to the value of alpha. So we have x is equal to r into cos of alpha. Similarly, we have y is equal to r into sine of alpha. Y coordinate is opposite, x is adjacent, opposite means sine, adjacent is cos. Let here x prime is a coordinate of point P prime and y prime is a y coordinate. So total angle transform here is alpha plus theta. So this adjacent side is same as x prime. This time it's a total angle with respect to positive of x-axis is alpha plus theta and is the adjacent side. So in this case we have x prime is equal to r into cos of alpha plus theta. Whereas this side, which one is opposite to alpha plus theta, in that case we can write y prime will be equal to r multiplied by sine of theta plus alpha. Whereas due to rotation the radius will not change, so we have r value is same here, so I am writing here the same value of r, that is r prime and r is one and same. So just expand this equation and we can develop the equation between x, x prime, theta and the value of alpha. Expansion of cos of alpha plus theta you have to write down here, so we have r into cos alpha plus theta is same as equal to cos of alpha into cos of theta minus sine of alpha into sine of theta. Now this expansion we can write as, since we know that r into cos alpha is same as x, so we'll club the first term as r into cos of alpha multiplied by cos of theta, and r multiplied by sine alpha is y, so we have minus r into sine alpha multiplied by sine of theta. So r cos alpha is nothing but x, so we have x prime is equal to x into cos of theta minus r sine alpha is same as y minus y times sine of theta. So anytime we can coordinate a new coordinate, just we want to know what is the angle between the original point and the new point. Similarly, we have y prime is equal to r into sine of theta plus alpha. In this case we can again expand Expansion of sine theta plus alpha is sine of theta into cos of alpha plus sine of alpha multiplied by cos of theta. Again we take the advantage of the definition of x, which is r cos alpha. So we have r into cos of alpha, which is same as equal to x multiplied by sine of theta plus r into sine alpha is y. So club r into sine alpha multiplied by cos of theta. Replace again r cos alpha is equal to x. So we have y prime is equal to x into sine of theta plus r sine alpha is equal to y into cos theta. So these are the generalized equation we can use to calculate x prime, which is x cos theta minus y sine theta, and we have y prime is equal to x sine theta plus y cos theta. You can represent this equation using the matrix. For this one we have the matrix P is here representing the x coordinate and y coordinate. So we have x and y. P prime is equal to x prime and the y coordinate is y prime. So in general we can write here the new point coordinate is P prime matrix is equal to P multiplied by R, where R is called as rotation matrix. We have P prime is same as x prime. So we have x prime, y prime. The coordinate of point P is same as x, y. Now check here, x prime is nothing but x into cos theta. So we have x into cos theta minus y into sin theta. So we have minus sin theta. Then we have y prime is equal to x into sin theta. So this term is same as sin theta plus we have y into cos theta, y into cos theta. So whatever the matrix we are getting here is called as the rotation matrix. We have taken here the value of theta is counterclockwise. So counterclockwise is taken as positive. If we are using the clockwise, then for clockwise you have to put the value of theta equal to negative value. Rest calculation will remain same. The third transformation that we usually carry out is a translation. By using a translation routine, it is possible to translate or shift a point or an object in the x and y direction. So suppose we have a point P. From origin it has a coordinate equal to x and y, and we want to shift this point to the new point equal to P prime, whose new coordinate will be equal to x prime and y prime. All the coordinates are measured with respect to point O. So the point P we want to shift to the new point equal to P prime, which has a new coordinate equal to x prime, y prime. In this case the x prime coordinate will change, y prime coordinate will change. It depends upon what type of translation we required along the x-axis and along the y-axis. So original coordinate we can show of the point P as x and y, and the new coordinate become x prime and y prime. So how much it is translated along the x direction? For that one you have to use tx unit and ty unit along the y direction. So here tx and ty represent the unit by which the point is translated in the x and y direction. This one is a simple geometry. We have x prime, that is a coordinate of point P prime, will be equal to x plus tx, x plus tx, and we have y prime will be equal to distance y plus ty is equal to y prime, y plus ty. So these are the three basic transformation that we have discussed. First is the scaling, second is the rotation, and third is the translation. In this case we have P prime will be equal to P plus the translation vector ts. So we have P prime can be written as x prime, y prime. This one is the row matrix. Similar to that we have P is also a row matrix x and y, plus we have the translation matrix is equal to Tx and Ty. So we have x prime is equal to x plus Tx, y prime is equal to y plus Ty. Now the size of the matrix here is 1 by 2. This matrix size is 1 by 2 and this matrix size also 1 by 2. This time it's called as translation matrix T. So in this case the addition is possible, and in the case of rotation we have P prime matrix is also equal to 1 by 2. This matrix is equal to 1 by 2 and this matrix is 2 by 2. So 2 by 2 will get cancelled and we'll get the same matrix as 1 by 2. In the scaling matrix we have used the column matrix, and in the translation and in the rotation we have used the row matrix. So this matrix is, so we have 2 row, 1 column is 2 by 1. This one is 2 by 2 matrix and this one is also 2 by 1. So 2 and 2 cancel, we get same as 2 by 1 matrix. Now if you want to perform the translation, rotation and the scaling together, you have to little bit modify here because this addition and multiplication is not possible. So that we'll discuss in the next video. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.